Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Foundation tier. Question number 5 is on the topic of forces. The stopping distance of a car is the sum of the thinking distance and the braking distance. What factors affect the thinking distance? Now, the factors that affect the thinking distance has got to be with the driver, because the driver obviously has the brain for thinking. Conditions of the tires, no. Driving on wet roads, no. Mass of the car, no. Tiredness of the driver, yes. Using a mobile phone, yes. Explain why a person should not drink and then drive. Okay, so why shouldn't you drink and drive? First thing, if you drink and drive, then your reaction time would be bigger or greater, right? If you are taking more time to react, then your thinking distance would increase. Because you're taking a lot of time to think, the car is going to be moving during the time while you're thinking. Hence, your thinking time distance would increase, right? This means the car travels further before stopping, meaning your stopping distance has increased, which means you are most likely to have an accident. The highway code gives information on how thinking distance depends on the speed of a car. Figure 7 shows the information as a graph. So as you can see, on the x-axis, the speed of the car in meters per second, and on the y-axis, the thinking distance. As the speed increases, the thinking distance is also increasing. What is the speed of the car if the thinking distance is 16 meters? So at 16 meters, which is just one box, okay, sorry, 16 meters here. So there's 5 boxes between 0 and 5. 5 divided by 5 is 1 meter, right? So the 16 is just one box. So where would 16 be? It's here, just 2 boxes away from this line. 2 boxes away from that line is 23. So the speed of the car when the thinking distance 16 meters is 23 meters per second. So let me mark that again. Go. And describe the relationship between speed and thinking distance for 2 marks. So as you can see, as the speed of the car increases, the thinking distance is increasing. If you describe it that way, you're just going to get 1 mark. You need to describe, the best way to get the 2 marks is to say, they are directly proportional. Simply saying that they are directly proportional will give you 2 marks. Why is it directly proportional? Well, when the speed is 10, actually let's say 15. When the speed is 15, you can see the distance traveled is about 11 meters here. But when this double the speed to 30, it goes to from 11 to 20. It's about halfway, 10.1. So 10.5, and then it's going to double that, which is 21 here. So when the speed doubles, this thinking distance also doubling. And that's why it is directly proportional. The highway code assumes the driver's reaction time is 0.7 seconds. Draw a line on figure 7 to show the relationship for a driver with a reaction time of 1.4 seconds. So if the reaction time is 1.4 seconds, let me choose a different color. So if the reaction time is 1.4 seconds, so time is going to be 1.4 seconds. Let's pick let's pick the speed. Let's say the speed is going to be 15, and then we are going to do it for 30 as well. What will be the thinking distance? Well, speed equals distance divided by the time. So distance equals speed multiplied by time. So if the speed is 15 and the time is 1.4, the distance is going to be, again, let's bring up the calculator. 15 times 1.4 gives me 21 meters. And if let's say at 30, again, distance is speed multiplied by 30 times 1.4. 30 times 1.4 gives me 42. Well, I don't have 42 in there, do I? I can't actually reach up to 42. So let's do 10, right? Rather than 30, let's do 10. That would make it 10 times 1.4 is 14. That's easy. Okay. So what I'm trying to do here is actually come up with 2 points on the graph. So when it's 10 and 15, when it's 10, the thinking distance is 14 meters. So that's over here. And when it's 15, when the speed is 15 meters per second, the thinking distance is 21 meters, which is here. Now it needs to be a straight line. Using a ruler, you should be drawing a straight line like that. Right, let me redraw it again. So my 21 is there. So right, that's good. That's as good as I'm going to get. But it needs to be going through 0 and both these points. That gives you the 2 marks. A car accelerates. Let's get rid of the calculator for now. A car accelerates at 5 meters per second squared over a distance of 45 meters. So 5 meters per second squared is my acceleration. Distance is given the symbol S. Initial velocity of the car is 0. That's my U. Calculate the final velocity, which is V. Use the physics equation sheet. Now, if you look at the equation sheet, you'll find this equation. Now, the reason it's 4 marks is because you will have to use this equation, which is called a SUVAT equation. V squared plus U squared equals 2A for acceleration, S for distance. Give your answer to 2 significant figures that carries a mark. So calculate the final velocity. v squared plus 0 squared is 0 equals 2 times acceleration is 5 multiplied by the distance is 45. So 2 times 5 is 10 times 45 is 450 is v squared. So to find the v, you square root 450. So what's the square root of 450? Okay, let's bring up the calculator. Square root of 450 plus the square root sign first and then the numbers. That gives me 21.21. 21.21 because they want the answer in two significant figures. So you'll have to round it up to two whole numbers, which means your answer is going to be 21. That brings us to the end of question number 5. I will see you in question number 6.